Okay. Now let's continue with question two. Now we're looking at climate and weather, which is question one. Question two. Now let's look at uh, geomorphology. What content are you expecting to be tested on? The content that you expect to be tested on will be the content that you expect to be tested on would be stream patterns, stream order, long and cross profile, fluvial landforms, stream piracy or river capture, and rejuvenation. Now, let's start first by looking at the typical examination questions. This one is on types of rivers. Now, here's the question. The river illustrated in the sketch is a permanent or periodic river. So you need to look at the sketch now. You have to check what's happening with the water table there. This is what is shown here. This is what is shown here. So that is your through flow. That is your water table. So this river here is permanent river. And why are we saying it's permanent river? Because we can see that the water table there is is in the riverbed. The riverbed is crossing through the water table throughout the year. So for dry season and for wet season. So you refer to this water table in the rainy season. There's water table in the rainy season and water table in dry season. So at both instances, the water table is always above. The water table is always, or the riverbed is always below the water table. The riverbed is below the water table. So the water table is above the riverbed, which means now there's always going to be a source of water throughout the year. So during rainy season, this river will flow because it has got two sources. Number one, it has groundwater as a source. Groundwater, it intercepts through water table. And number two, there is precipitation. And during dry season, there's only going to be groundwater that is supplying the river. So this river is going to flow permanently or throughout the year. The question says, state two characteristics of the river system evident in the sketch. Now, what is it that you see in the river? Give evidence from the sketch that the surface runoff is greater at A than at B. So this is A and this is B. Give evidence from the sketch that surface runoff is greater at A than at B. So we have to give that. We'll look at the answers there. Which one of the cross sections Y or Z represents the river at point C? So the river at point C, which one? Is it this one, Z, or is it Y that represent the river at C? And then give reasons for your answer. How will a decrease in precipitation affect the following water table or type of river? Now, let's look at this. We said the river is permanent. And now, the question is, what is it that you can see? State two characteristics of the river system evident. What is it that you can see here? What is it that you can see? You can see the dendritic pattern. Can you see the dendritic pattern? Here is the dendritic pattern there. Can you see it? What else can you see? The volume of water increases from source to mouth. Now you can see the line here. There's the source. You can see the line here is getting darker to ensure that the water is increasing, and here the line is thinner. So that's what you can see there. What else? There is high water table. Tributaries are divided by interflows, second order streams, low drainage density, permanent. So how do you tell low drainage density? You can see there are few streams there. There are few streams there. That's evident that you can see. The river is permanent. The river intercepts the water table in wet and dry season. And there is gentle gradient. There is gentle gradient. This gradient is not so steep. What else can you see? The tributaries are joining the main streams at acute angle. Just because we said the river is dendritic, now those are the characteristics of dendritic pattern. Let's go to the next question. Give evidence from the sketch that the surface runoff is greater at A than at B. Now, how do you tell that it's greater at A than B? There is less vegetation at A. More tributaries feed the channel at A. The channel at A is wider, higher volume of water at A. A is in the middle or lower course, higher stream order at A. So these are the characteristics that you should know, that volume of water will be higher there than volume of water will be higher at A than at B, because the volume of water increases as the river flows towards the mouth. And then, which one of the cross sections, Y or Z, represents the river at point C? Now, there is your river at point C. Which one will represent the river at point C? Is it Y or is it Z? Now, how are you going to look at that? Answer there says Z. How do you determine that it is Z? So at Z, this is at the lower course where the river, where the volume of water has increased. And now you can see that the water table, or the riverbed, the water table rather, yes, it is above the riverbed. The water table is above the riverbed for both seasons, for both wet season and for both dry season. Which one? Give a reason for your answer. You give the answer. I've already given the answer. Is because the water table is above the riverbed for all seasons. How will a decrease in precipitation affect the following water table? Now, this question can come in number of ways. This question can come in number of ways. In this question, it says, how will decrease in precipitation affect the following water table? Number one, water table. If there is a decrease in precipitation, the water table will be lower. And how will that affect the type of river? The type of river will change from being permanent to being periodic. Now, if the question is not saying decrease, when the river says increase, now you're going to give the different reason now. Let's say examiner does not say how will a decrease. It says how does the increase in precipitation. Now it's what will happen to water table. Water table is going to go higher and the river will flow throughout the year. Now this is application question. One of the question could be, how will prolonged drought, let's say, how will prolonged drought impact on water table? So drought is also going to result in drop in water table. It is also going to result in a river becoming periodic. Now, sometimes they can ask you, how will the extraction of a well, like something that we are going to use to extract groundwater, how will the extraction of well impact on the water table? The well, because water is going to be now used from the groundwater will be used. Now it means now the water table will also go lower. So this is an application question. It can take any form and direction. It can ask you about the increase in rainfall, a decrease in rainfall, or it can be again, how will the construction of urban settlement, how will the construction of urban settlement impact on the water table? Now, you can decide, okay, when we do urban settlements, what do we increase? We are going to increase surface runoff. Now, when we have an increased surface runoff, it means now there's going to be less infiltration, and therefore the water table will also drop because there is going to be more runoff and less infiltration. So that question can take different application strategies. You could be asked to apply a number of ways here. Now let's continue with our question. One of the questions that one of the topics that you must know is your dendritic. Not dendritic is your stream patterns. Now we are looking at the most common patterns here. We have radial pattern. We have this one as radial. You can see the streams are radiating from the high point, and then what is important when you do drainage patterns? There are three questions that you need to know. Number one, you need to be able to identify a pattern. The question is, you need to be identify drainage pattern at A, identify drainage pattern at B, at B, at C, and at D. You must be able to identify. That's number one. Number two, you need to explain the underlying rock. Underlying rock simply refers to where is this drainage pattern found, or where can this drainage pattern develop, or yes, where could this type of pattern be located. And number three would be you need to give the characteristics. You need to give the characteristics of each pattern. So these are the main questions that you should know when you're talking about drainage patterns. Your questions, or how does so the question could be, how does the underlying rock influence the flow? So now the question could be, how did the underlying rock influence the pattern here at the radial pattern? It's because the high-lying area make water to radiate. So it is application question. You need to be able to apply the knowledge that you have studied in class. Except for you knowing that it is dendritic, you must know dendritic is found where rocks have uniform resistance to erosion, and it does not look like a tree. It looks like the branches of a tree. It looks like the branches of a tree, not like a tree itself. And then trellis pattern, mainstreams are parallel to each other. It has short tributaries. And then this one, you should know the tributaries here are acute. Here, the tributaries here are 90 degrees. So the difference that you should know about that. And here, the tributaries are shorter. And then with the rectangular pattern, you must know that the streams follow the joints or the bends in the main river. So what is common with the two patterns, with the trellis and rectangular pattern? What is common with that is that the tributaries join the mainstreams at 90 degrees. The tributaries join the mainstream at 90 degrees. But with dendritic, the tributaries join the mainstreams at acute angle. So that's the difference, and those are the differences and the similarities between the three drainage patterns. And then let's continue with our drainage patterns. So you should be able to identify them from the maps. So an examiner could take a portion from the map and say in block A1, block A2, identify this drainage pattern in block A1 or A2. So you must be able to identify the patterns in looking at the particular block. And then this one over here you can see is trellis, and then the development of trellis pattern is where there is hard rock. You can see this one is hard rock, and here you have the streams. It shows the rocks here are softer, hard rock. So the rocks is hard rock, soft rock, hard rock, and that is that, which is different from the dendritic pattern. Dendritic pattern, you can see the type of rocks here are the same. So it means there is similar resistance to erosion. But here you can see there's varying resistance to erosion, because at one point the stream and the rocks are harder, and at one point the rocks are softer. And this is radial pattern. You can see we have a high lying area, and the streams are flowing away from each other. And then what do we have here? We have igneous rock, but we can see the igneous rock have got cracks. So the streams are following the cracks in the igneous rocks. So that is your rectangular pattern. You must be able to answer those questions. So these are the characteristics, as you studied them throughout the year, you're looking at the diagrams, you should be able to identify these diagrams. And then you must also make sure that you are able to differentiate between the different patterns. And then there is another pattern here that is missing here, which is a parallel pattern that looks more like the dendritic pattern, but a dendritic pattern that is a little bit more straighter. That's your parallel pattern. So you must be able to identify different patterns. And then how do we describe the dendritic pattern? You say it looks like the branches of a tree and tributaries join at acute angle. And then where is it found? Where rocks have got similar hardness or similar resistance to erosion. Then you have your trellis pattern. The characteristics of trellis pattern is that you have parallel main streams, and you have tributaries that are short, and they join mainstream at 90 degrees. So where is it found? The underlying rock is gently sloping alternating layers of hard and soft rocks. Sometimes you can also say it is fine where you have your incline strata, And now radial, like the name say, radial, it radiates from the high point. It looks like the spokes of a wheel viewed from above, and river flow away because it radiates. The river flow away from a central point. Then what do we have there? You have a rectangular pattern. So with a rectangular pattern, we can see again, like we said, the mainstream have got 90 degrees bend, and the tributaries join the mainstream at 90 degrees as well. And we have centripetal. Centripetal is opposite. Centripetal is opposite to radial. The streams are flowing towards the low-lying area. Streams flow towards a central basin, such as marsh or lake. Then we have this pattern, which is called deranged. The name say is deranged. Small streams that have no specific pattern. The streams flow into the lakes, out of the lakes, like that. So it doesn't have a definite pattern. And we have parallel pattern here. You can see the streams will look more like the streams in a dendritic pattern, but the streams will be parallel. They will be flowing parallel to each other. Usually it's going to happen where we have ridges. They will occur mostly where the area is very steep. So that's where you're going to get your parallel pattern. Now let's look at let's continue with this. What's happening with my slide? Okay. Now, here's a short activity that you can do based on a strength pattern. Strength patterns. So what do we have there? Indicate whether each strange pattern A, B, C refers to landscape 1. So you must be able to show which landscape will result in which straight pattern. So there they are. We can see which one develops there. This one is a radial. That's the radial there. Now you can see here they have got bends. So that's your rectangular. And here you can see the parallel mainstreams there. You can see the parallel mainstream, the hard and resistant rock. So that will be the example there. And this is coming from a previous question paper. Now, drainage density. So when you speak of drainage density, you must be able to define what is drainage density. So density, we're simply referring to the total length of streams divided by the total area of the drainage basin. So when you're looking at this two, when you divide this, you can see here at the bottom here, we have fewer streams. And then when you're looking here, above here, we have more streams. So when we have more streams, we have higher density. So there are two processes that are responsible for drainage density. There are two processes that are responsible for drainage density. The processes that are responsible for drainage density, number one is infiltration. And the second one is runoff. These are the two processes that influence drainage density. These are the two processes that influence the drainage density, runoff and infiltration. So runoff or surface runoff is the flow of water on the surface, and infiltration is the absorption of water by the earth's surface. Now, when you're looking at this question, there are factors that are going to influence drainage density. There are factors that are going to influence drainage density. Number one, it will be vegetation. Now, if you get a question that says, explain how did vegetation influence the drainage density at A? So this is A, and this is B. If the question says, explain how did vegetation influence density at A, you will say, at A, there is less vegetation, and therefore there is more at A, there is less vegetation. As a result of that, there is more surface runoff, which results in higher density, and there is less infiltration because you can see a lot of water is flowing on the surface. And then at B, how did vegetation influence the density at B? How did vegetation influence density at B? Then you can say at B, there is more infiltration at B. There is more infiltration, and therefore it's because now there is more vegetation at B. Because of more vegetation at B, it resulted in more infiltration and less runoff. That is why we have lower density. So when you're looking at the factors that influence drainage density, number one, remember you have vegetation. Number two, we have gradient. We have precipitation, type of precipitation. We have soil moisture. Now, we've already accounted for vegetation. Now, let's look at this too in terms of soil moisture or type of soil. Now, when you're looking at A, what is the type of soil? The type of soil here, or the type of rocks here. At A, there is hard rock. Because of hard rock, what is happening? At A, there is hard rock. Because of hard rock, what is happening? There's going to be more surface runoff and less infiltration. That's why we have more water flowing, causing high density. And at B, what is happening there? There is a soft rock. The rocks here are softer, and therefore there is more infiltration and there is less runoff. That is why the density is low. And then we also look at the gradient. how did the gradient influence the density at A? It means now at A, the gradient is very steep. Because of steep gradient at A, that is why we have high runoff and we have less infiltration. That is why it resulted in what? In higher drainage density. And now, what is happening here? At B, B indicates that the gradient here is very gentle. Because of gentle gradient, what is happening here? There is more infiltration and there is less runoff. There is more infiltration, less runoff. Hence, we have lower density. What do we mean lower density? Hence, we have fewer streams. We have fewer streams because most of the water infiltrated. But here, most of the water is running on the surface. Is doing what we call surface runoff or is flowing. And now, between the two, at A, what is happening here? Why do we have high density at A? We have high density because the soil has more moisture. The soil is saturated. Because of saturation, during precipitation, there is less infiltration taking place, but there is more runoff taking place. That is why we have higher drainage density. But when you're looking at B, what is happening there at B? At B, the soil is dry. So there is less soil moisture. That is why during precipitation, there's going to be more infiltration and less runoff. That is why it results in low drainage density. Okay, so these are the factors that are going to be influencing the drainage density at A and B. So you must be able to explain how drainage density is affected by a number of factors. You must be able to, because the question could come in a scenario question saying, how did vegetation influence density at A? Or how did gradient influence density at B? Then you must say at B, the gradient is gentle and therefore there is more runoff, there is less runoff, more infiltration. That is why at B, the drainage density is low. So that's an application question, and that is how you can answer those application questions. Now, let's quickly look at the activities here that we have. Now, we have these activities. Dense vegetation cover that prevents a surface runoff. So here at B, you can see there is less infiltration. At B, you can see there is less runoff. Why do we say there's less runoff? Because there's few streams. So it means here there is dense vegetation here. There's more trees and grass. There is more vegetation. Therefore, there is more infiltration and there is less runoff. Drainage basin that experience high rainfall. Because of high rainfall, water doesn't have time to infiltrate because it rains regularly. Therefore, there's going to be high drainage density. Drainage density that has mainly clay soil. Clay soil does not allow water to pass through easily. So we have this, what we call aquifer. We have what we call aquifer, and we have what we call aquiclude. We have what we call aquiclude. What is an aquifer? It's a surface that allows water to pass through easily. And what is an aquiclude? Is the surface that does not allow water to pass through easily. Now, a clay soil is an aquifer, and it's an aquiclude, sorry. It is an aquiclude. It does not allow water to pass through. So if the water is not passing through, it's not infiltrating, then it means water is going to flow on the surface. So A is a clay soil because there is more water on the surface. Drainage basin that has mainly permeable rock. Permeable rock meaning that the surface is porous. So it means there are many pore spaces here. It means there are many pore spaces here. And then what will pore spaces do? Pore spaces will allow water to infiltrate. So B has got a high level of porosity. Because of high level of porosity, B will also be permeable. But A is less porous. There are few pore spaces for water to pass through here. There are few pore spaces for water to pass through. So there is a relationship between porosity and permeability. The higher the pore spaces, or the higher the porosity, the higher the permeability. What is porosity? Porosity simply refers to the pore space per unit area. Pore spaces per unit area. So here there are many pore spaces per this area, but here there are fewer pore spaces per this area. So area B has high porosity, and because of high porosity, area B will be more permeable, and therefore is going to allow for more infiltration, and is going to result in less runoff. But A is less porous. The porosity here is low, and because of low porosity, there's also going to be low permeability. That is why we are going to have more runoff here, because most of the water is going to be found on the surface, but here most of the water is going to infiltrate. Drainage basin that has mainly permeable rock, so we can say B has got permeable rock and A has impermeable rock. A river that flows through hilly areas refers to steep gradient. So because of steep gradient, there's going to be more runoff and less infiltration. But here it will be on a gentle gradient. Drainage basin that has porous rock with sandy soil. Here B has high porosity, like I explained, and there is more infiltration and less runoff. That is why we have low density. But now when we're looking at A is less porous, and therefore there is less permeability, and this is clay soil, and there's going to be a high runoff. A river that flows through gently sloping land. River B is flowing at gently sloping land because there is more infiltration because of gentle gradient, and there is less runoff, and there is going to be less low drainage density. Now, let's look at this. This is a similar question to that. Now we're looking at which one has got lower infiltration rate. Lower infiltration rate will be at B. There's low infiltration, there's high runoff. Denser vegetation at A. Higher soil moisture at B. Because of soil moisture, there's less time for water to infiltrate. Developed on the least resistant rock. It's least resistant. A is least resistant, which means the rock is soft. So there's going to be more infiltration and less runoff. Lower degree of permeability. This one has got lower degree of permeability. There is less, this area is less permeable, and therefore high runoff and less infiltration. High stream order, there are more streams order. There are more streams here than here, and therefore it will result in higher stream order. The graph below represents this drainage basin. Which graph here will represent this drainage basin? So, graph 1 will represent a drainage basin. Drainage basin B, and this graph will represent drainage basin A. Okay, now this is stream order. What do we look at when we're looking at stream order? First, we're looking at the streams, first order streams. All the tributaries in a drainage basin are referred to as stream order 1. Now, when stream order 1 and stream order 1 join, they make stream order 2. But you must be careful now when you look at them. You have stream order 1 and stream order 1, they make stream order 2. You have stream order 1 and stream order, they make stream order 2. But you have stream order 1 and stream order 2, they remain at 2. So when two streams of a different order are joining, the stream order is not going to change. It's going to remain at the highest order. If the highest order was at 2, it remains at 2. If it was stream order number 3 and stream order number If it's stream order number 1, joining with stream order number 3, is going to remain stream order 3 here. It's going to remain at stream order 3 here. The order is not going to change. Only if it's stream order number 3 and stream order number 3 that are going to join. Only if it's stream order 3 and stream order 3 that are joining, it will remain in stream order 4. But if you have the highest order and the lowest order, the order remains at the highest point. You can see here, we have 1 and 1, it makes 2, but we have 1 here, then you have 2 here, they all join here, it remains 2. We have 1 here and 2 here is also going to remain at 2 here because they are of a different order. So stream order, we're just looking at 1 and 1. If it's 1 and 1, they graduate to 2, and 2 and 2 go to 3. 3 and 1 remains at the highest order. 3 and 2 remains at the highest order, which is 3. 3 and 3, it moves to the higher, it moves to the next level. It's 4. And then 4 and 3, it remains at 4. And 4 and 4 goes to 5. So it goes like that. 4 and 5 is going to remain at 5, and 5 and 5 is going to move to 6, just like that. So it remains at the highest order. But if they are of the same order, they move to the next level. Now let's look at a river discharge. A river discharge, you must be able to define what is a river discharge. Is a volume of water as it passes a specific point at a specific time. It's a volume of water as it passes a specific point at a specific time. Now we have two types of a river discharge of flow characteristic, which is laminar flow and turbulent flow. Laminar, water is flowing in layers, is flowing on a gentle gradient. And turbulent flow, water has turbulent, it swells like that, and it's flowing on an uneven riverbed. So water flows as a parallel sheet. Riverbed is even, less erosion, lower cost. So this is a river and at its lower cost. And turbulent, there are rapids, there are waterfalls, there are a lot of obstacles along the river course. These obstacles that we call nick points. These obstacles along the river course that we call nick points. They are going to make the river to flow on an uneven surface, and that flow characteristic is called a turbulent flow. Now we're looking at longitudinal profile of the river. What is a longitudinal profile of the river? Is the view of the river from the source to the mouth. Is the view of the river from where it starts to where it ends. That's what we call a longitudinal profile of the river. Longitudinal profile of the river is the view of the river from the source to the mouth. Now we have the stages of the river. We have the upper course. What are the characteristics? It is steeper. Now, it is steeper and water is flowing fast. So the water is very little. There is little amount of water, but the water is flowing fast. Why is water flowing fast? Because of a steeper gradient. And the type of the characteristics of erosion here, or the type of erosion, is downward erosion or vertical erosion. Is downward erosion or vertical erosion. And what are the features that you're going to find along the river? In the upper course, it will be your waterfalls, your rapids, your interlocking space. These are the features that you'll find in the upper course. And then the valley, the cross section. So this is a longitudinal profile. This is a longitudinal profile. Longitudinal profile. And now, what will the longitudinal profile of a river show you? Longitudinal profile of the river will show you the side view of the river, and it will also show you the length of the river. Now, when you're looking at the cross profile of the river, what will you see from the cross profile of the river? You will see the depth of the river. You will also see the width of the river. Those are the characteristics of a river that you will see from the cross profile of the river. Now let's go to the middle course of the river. Middle course of the river, what are the flow characteristic? The gradient there is gradual. The water is flowing slow. There is lateral erosion, and you are going to find the meanders that are beginning to form, and you also find the space. Remember, in the upper course, you're going to find the interlocking space, but in the middle course, you will find the space. That's what you will find. And now, let's look at the cross section of the river in the middle course. So you can see now the valley is wider. What made it to be wider compared to the upper course? So here we're saying it is U-shaped. It is U-shaped, which is slightly wider than the V-shaped. But why is it wider like that, or why is it a U-shaped? It is mainly because of lateral erosion. So lateral erosion results in the widening of the river. It results in the widening of the river, but when looking at the vertical erosion, it results in the deepening of the river. So what do you see from the cross section? You see the width and you see the depth. So the cross section, what dimensions can you see from the cross section? You see the depth, you see the width. Then you can compare, you say the river is deeper in the upper course, but it's wider in the middle course compared to the upper course. But now, when you proceed and go to the river in its lower course, you will see now the river is at its widest because it is the gradient there is almost flat. It's almost flat. It flows very slow because of a gentle gradient. And then this is the point of the river where the river has the highest volume of water. The river in its lower course, it got the highest. You can see here the volume of water here. Just little volume of water. Here the volume of water has increased, but here the volume of water is at its highest. The volume of water is at its highest. But now, there is more deposition. Why is there more deposition? Because the river is flowing slower because of the gradient is almost flat. And then what are the features that you're going to find? You're going to get the oxbow lakes, the deltas, meanders continue. We're going to have meshes and braided streams and sandbanks. Those are the features that you're going to get at the lower course of the river. Now, this is the continuation of the longitudinal profile of the river. You have the upper course, middle course, and then this area that you're looking at here, this green area, this is what we call the floodplain. This is what we call floodplain. You can see it is nice and green. You can see it's nice and green is because it has got the deposition. You remember we said this is floodplain. What is happening? Floodplain. The way it said floodplain, it calls floodplain. There's a name. So it means now a lot of flooding is taking place, which means there's going to be alluvium. There's going to be alluvium that is deposited there. Alluvium being the fertile soil. So now this floodplain is very useful for farming. What makes it useful for farming? It is its gentle gradient. Number two, it is access to water. Number three, it is a flat gradient. It's flat gradient, number one, makes it useful for farming. It's fertile soil, makes it useful, and access to water makes it very fertile. But now there's a risk of flooding again there. The risk there's a risk of flooding because it's at its lower course where the river volume is higher and the volume, the river, the gradient is very gentle, so there are higher chances of flooding. So there are a number of factors for and against you using the floodplain. And then here in the mouth, these are the features that we call delta. The delta occurs when the river breaks into distributaries. when the river breaks into distributaries. So the distributaries will be the small streams that break from the mainstream as the river flows into the sea. Remember, the tributaries join the river, but the distributaries break away from the mainstream. So this is a continued characteristics of a river profile. And now what we have there. So because here we can see, all we see here is contour lines showing that the area is very steep. So this will be the upper course of the river. It is steeper, the water is flowing fast. The dominant erosion here is downward erosion, and the features that you are going to find is waterfalls, rapids, and interlocking spares. Then we go to the middle course. Here you can see it's middle course because the river is gradual, it's not so steep. You can see there is a lot of farming taking place around here. You can see there's cultivated lands and there are orchards. So there's a lot of farming taking place here. You can see we have orchards there, we have cultivated lands there. Cultivated lands. You must be careful between orchards and cultivated land. So many times people confuse cultivated lands and orchard because of not paying too much attention to detail. So this is the river in the middle course. Then the examiner can ask you what measures have been taken into consideration to mitigate or to reduce the chances of flooding, because in the middle course the river is gradual. So you can see there's a lot of dams, there's a lot of storage dams to reduce the water that could flow on the surface. So these dams here could be used to reduce flooding, or they can also be used to store water to use during dry seasons. Now there is a river in its lower course. So this is a braided stream. Now you must be careful between a braided stream and the delta. So a braided stream is a river. It's going to have the islands like that, the sand islands like that. It will break, but it will also join. The river will break and join. So this is what we call a braided stream. But when it's a delta, the river is just going to have distributaries. The river will have distributaries, and those distributaries will not join again. Those distributaries, each stream will be flowing into the sea. But here, what do we get here? We have a braided stream. So what you can see there, you can see you have your marshes there and flays there. You have your sand deposit or sand banks, sand banks here that you can see there. So this is your braided stream. And then what do you have there? You have a meander. You must know what is a meander. A meander, this is a meander, which is a bend. A meander is a bend. So a bend in a river course is called a meander. So sometimes examiner asks you what is the what is the feature? What is the feature? So when you're looking at it like that, that feature is called a meander. So now we're looking at the river, from the side like that. So we have what you call graded and ungraded profile. We have graded. So why is this river ungraded? Because there are obstacles or there are nick points. Why is this river graded? Because it has got a smooth concave profile. This river is graded because of the smooth concave profile. So these are the nick points. These are the nick points or the obstacles. The temporary base level of erosion. We call them temporary base of level of erosion because they can change over time. Now, this is the course profile of a meander. This is a meander. So in a meander, the outside of a meander is called an undercut slope. The water is flowing faster on the outside. And then because of faster moving water, there's going to be erosion. And on the inside, you can see here, we've got a lot of deposits here. because water is flowing slower, so there's a lot of deposition. And what is the name of the inside of the slope? It's called the slip of slope. That is where material is slipping off, and it is deposited there. Now we have the cross section here. So if you are to draw a cross section of a meander, you must just identify which side of the meander is deeper and which side of the meander is shallow. So if you are able to identify which side is deeper, all you do, you draw a Nike sign, So that is your Nike sign. So if your deeper side is on the side, then your Nike side will face to the right. If the deeper side is on the other side, your Nike sign will take a different direction. So all you do, you put a Nike sign for you to represent a cross section of a river, or a cross section of a meander rather. Now that's your features of a drainage basin. You have the river. The source will be a point where the river starts. Then you have all these characteristics. Now let's look at I was talking about delta. So we see what the difference between the delta and a braided stream. At this point, we have a braided stream. So you can see at this point, a river is breaking and the river joins again. So that's your braided stream. But with a delta, a river is going to break into these tributaries as it flows into the sea. So these tributaries are not going to join again. So this one will have, both of them are going to have sand islands. We're going to have sand islands between them, or between the streams. But here, it's going to join again as the river continues. And now, what do we have there? You have your Oxbow Lake that is going to later on become so this one already we can see that this one doesn't have water. So now it becomes a meander scar. So when it contains water, it is an Oxbow Lake. So once it becomes dry, we no longer call it an Oxbow Lake. We call it now a meander scar. And now that's the development of a meander. Now, sometimes the examiner can ask you, where will the Oxbow Lake more likely to form? At 1, 2, 3, 4, and you can say it's more likely to form at 4. Why? Because you're saying the meander neck. This is the meander neck. So the meander neck here, you can see it is wider. The meander neck here is wider. So at 2, you can see the meander neck is narrowing. It's narrower than at 1. And then here you can see the meander neck has already been cut now. Now we have a Oxbow Lake. So the width of the meander neck is the one that is determining how close is the river from cutting its meander loop. So this is what we call a meander loop. This is a meander loop. Meander loop. So once this meander loop has been cut from the mainstream, we call this an Oxbow Lake while it has water. Once the water dries out, then it is called a meander scar. So there is your river in its lower course. You can see the gradient is very gentle. You can see the Oxbow Lakes. You can see the meanders there, but there's no Oxbow Lake. All you can see there is the meanders that you can see. Now, the river, what you can see here, you can see this will be your Oxbow Lake, and later on it will be cut from the mainstream. Actually, this is still part of the meander because it is still a join to the river. There's still joining of the river until there is deposition this side, and this is on its own. Then it's going to become your Oxbow Lake. It's going to become your oxbow lake. But once it's still, so like this one here that is now flowing on its own, you could look at it as the oxbow lake like that, because now this has been completely cut and this one has been completely cut from the main river. And this process will also take place here again, as this river will now cut through here. It will cut through here as it goes in that direction, and that part will run on its own and becomes another oxbow lake. Now, another process that you need to pay attention to will be stream piracy. What is stream piracy? Is when an energetic stream diverts headwaters of a less energetic stream, or when a river with more energy diverts the headwaters of a river with less energy, or when a river flowing on a steeper gradient steals water of a less energetic river. I don't want to use the word steal because it is not a geographical concept. The geographical concept will be the water diverts a stream, not steal. I don't see river stealing. So we have, let's look at the process, what's happening here. So for river to divert headwaters, now we have two rivers here. We have two rivers here. We have two rivers. This river flowing on a steeper gradient, and this one flowing on a gentle gradient. Now, when this river flows in this direction, what do you call this process? We call it headwater erosion. What is headwater erosion? This water is flowing in this direction, but erosion is taking place in the opposite direction. The erosion takes place. So what process is going to take place here? We're going to get headwater erosion taking place. And this headwater erosion is going to result in the removal of this watershed. And then that process where this watershed is cut, what do you call this process? We call is this process here. We had watershed here. Now, when this watershed is no longer there, is removed, this process is called abstraction. Abstraction is the shifting of the watershed. So the watershed was this high. Because of headwater erosion, it was this high. Now, because of headwater erosion, it cut through the watershed. Now, we no longer have watershed here. The part of watershed that was here has been lowered and removed. Now, we call that process abstraction. Is the lowering and the removal or the shifting of the watershed. The shifting of the watershed or the lowering and the removal of watershed, that's what we call headwater. That is called abstraction. What causes abstraction is headwater erosion. When the river erodes towards the source. When the river erodes where it's coming from. Remember, water must fall on top here and it flows in that direction, falls on top here and flows in that direction. So this side is steeper, that is why there is more erosion. And then when this erosion continues to take place, this headwater erosion, this river joins this river. Now, because now this water, the area here is steeper, water is not longer going to flow towards a gentle gradient. Water is going to flow because of the steep gradient and takes direction. So what has taken place at this point there? At this point, this is a point where we call elbow of capture. That is where river capture has taken place. That is where diversion has taken place. Where the river diverts, where the energetic river diverts the headwaters, which is the water from the source. Headwaters is the water from the source. This river is flowing from that direction, going in this direction. Flowing from that direction, going in that direction. But now, But now, because this one has steeper gradient, once it joins, water is no longer going to go that way because it's gentler there. It's going to go this way because it's steeper. Then you have this point there that we call elbow of capture. And then now, because this stream has changed direction, it's called a captured river or captured stream. And this one, because it no longer has enough volume of water, is a mass fed stream. It's a mass fed stream. It's not as fit as it used to be. It has lost water. And this one is called a captor stream. Now, what you should be able to do, you should be able to answer or give the characteristics of river capture before and after the process. The characteristics of captor stream before and after. So you must know here, it will be plus, plus, plus. Why it was able to do capture is because it had more water. Why was it able to do capture? Because it was on a steeper gradient. Why was it able to? Because it was moving faster. And this one is negative, minus, minus. Why was it captured? Because it was flowing on a gentle gradient. It was moving slower. And then still after capture, what will happen to this river? It will have lesser water. This one will have more water. This one, after capture, before capture, it had more water. After capture, it will still have more water because you have now captured another river. And this one here, it had less water. And after capture, it will still have less water. And now, you also have to give those characteristics, having less water, and then how will less water influence erosion? There's going to be less erosion, but there's going to be more deposition. What will happen on the side? There's going to be more erosion, and there's going to be less deposition. So you just look at the characteristics of increased volume of water and decreased volume of water. And this area where water used to pass, water is no longer passing here. What is passing here is the wind. So we call this place wind gap. Now, disadvantages will be water shortage, farming, fishing, recreation. But as much as you can look at the impact of river capture for the surrounding, you must also know the impact of river capture on the rivers themselves. The impact that the river capture will have on the capture stream and on the capture stream. We said on the captured stream, there's going to be less volume of water, more deposition, less erosion. Here, there's going to be more volume of water, less deposition, more erosion, high chances of flooding. And then also you must know that the wind gap, there is more gravel at the wind gap and there is less water. Okay, this is another animation of river capture. It's the same as that one. Now we can look at the characteristics of river capture. These are the questions that you can expect from river capture. Now let's look at river rejuvenation. What is river rejuvenation? When the river starts to flow faster. River rejuvenation is when the river starts to flow faster, and then you need to look at the reasons why will a river rejuvenate: because of the drop in sea level, because of the land that has risen, or because of increase in rainfall, because of faster flowing water, or because of stream piracy. These are the causes. These are the causes of river rejuvenation. In river rejuvenation, it is important for you to know the features. River rejuvenation, the features of river rejuvenation. How do you tell that a river rejuvenation has taken place? Number one, the features of river rejuvenation that you should know is that river rejuvenation takes place at a neck point. It takes at the neck point. So you must be able to define as a neck point is where there is a sudden change in the gradient of the river. what is a sudden change in the gradient of the river. So your unique point can be a waterfall, it can be a dam wall, it can be anything. And then the features are the features of river rejuvenation. You can tell there's a unique point, there's a incised meander, there's terraces, there's waterfall. Now let's look at this terraces. So the river was flowing down there. It was flowing up here before. It was flowing up here. This was the initial valley. Then it stopped flowing, and after some time, it did vertical erosion. So at vertical erosion, then the river flew at this point. So this will be the next valley. And then after some time, the river rejuvenated, then it flew there. And over time, it flew there. Now the river is lower there. So it shows you that a river has got steps. Now, these steps of the river are called terraces. These are the steps of the river. So it shows that rejuvenation has been taking place over a period of time. So we can look at that, those are the traces, and these are the incised meanders. So when you say a meander is incised, it simply means that the meander is entrenched, is inside a hole. So it means now rejuvenation took place when the river was already meandering. So what has happened with the meanders? The meanders just got deeper because the meanders has already started and the river has now, the river was meandering and then it lost energy, then it gained energy to erode vertically again. So when it gains energy to erode vertically again, we call that process what? We call it rejuvenation. So once that happens now, it means now the meanders are going to be deeper. So those meanders that are deeper, we call them incised. You can see the landscape here. You can see the landscape here that the area is relatively flat. The area is flat. So it could be in the middle course of the river, it could be in the lower course of the river, but the river has gained more energy. Now, when it gains more energy, so there's going to be downward erosion. There's going to be downward erosion that is going to make these meanders to be deeper. Because now the process of downward erosion and the process of upliftment of the land were taking place. So the downward erosion was deepening the meander, and then the isostatic uplift was also making the level, the area to go higher because of isostatic uplift. But the rate of erosion was higher than the rate of isostatic uplift. That is why now the meanders got deeper and deeper because of renewed energy of erosion there. Now, another evidence that a river rejuvenation has taken place, it could be a neck point waterfall, which is a point where rejuvenation take place. I think we will stop at this point because we did not prepare more lessons on the network because of it have been longer session to do both the climate and geomorphology, summarizing them for a one lesson. I want to thank you at this point.